Can an atom, the fundamental building block of everything around us, be compared to a delicious plum pudding? Well, for a while, that's exactly what scientists thought. But then, in the early 20th century, a man named Ernest Rutherford turned this plum pudding theory on its head. Rutherford, a physicist from New Zealand, set out to understand the inner workings of the atom. He designed an ingenious experiment using something called alpha particles. These particles, each made up of 2 protons and 2 neutrons, are positively charged and are emitted by certain radioactive substances. Rutherford's team directed a beam of these alpha particles at a thin sheet of gold foil. He expected the particles to pass straight through, just like bullets through a piece of tissue paper. This would confirm the plum pudding model of the atom, where the positive charge is spread evenly, like the plums in a pudding. But something strange happened. While most of the alpha particles did pass straight through the foil, some were deflected, and a few even bounced back. This was as surprising as throwing a tennis ball at a wall and having it come back to hit you. This unexpected result led Rutherford to a new understanding of the atom. He proposed that the atom is mostly empty space, but at its center is a tiny dense nucleus carrying a positive charge. The alpha particles that bounced back had hit this nucleus, while the ones that went straight through had passed through the empty space. This means that the atom is not like a plum pudding at all. Instead, it's more like a tiny solar system, with electrons orbiting the nucleus like planets around the sun. This model, known as the nuclear model of the atom, was a breakthrough in the field of atomic physics. To summarize, Rutherford's experiment showed us 3 key things. First, the atom is not a solid sphere as once thought, but mostly empty space. Second, at the center of this space is a tiny dense nucleus carrying a positive charge. And third, the electrons are not embedded in the atom like plums in a pudding, but orbit around the nucleus. So next time you bite into a plum pudding, remember that it's not the best model for an atom. Instead, look up at the night sky and think of the planets orbiting around the sun. That's a much closer approximation of what's happening in the tiniest particles of the universe around us. Thanks to Rutherford, we now understand the atomic world a little better.